What's happening there, guys, and welcome back to our channel. The Bell Boeing V-22 is an American multi-mission tilt-rotor military aircraft with both vertical takeoff and landing, or VTOL, and short takeoff and landing STOL capabilities. It's designed to combine the functionality of a conventional helicopter with the long-range, high-speed cruise performance of a turboprop aircraft. Now let's have a look at the world's fastest helicopter, the V-22. But before we do that, please be sure to like this video and subscribe to our channel so you don't miss out on any of our future videos going forward. Number 5. Launch of V-22. The 1980 Iran hostage rescue mission's failure, Operation Eagle Claw, made clear to the US military the need for a new sort of aircraft that could not only take off and land vertically, but could also carry combat soldiers and do it at speed. Under the direction of the American Army, the JVX aircraft program was launched by the U.S. Department of Defense in 1981. The USMC's amphibious landing machine has served as its defining task, and the military got interested in the JVX program right away. Airborne aircraft with strong speed and range allowed for fast dispersal, and their CH-46 C9s were wearing out as they realized that a concentrated force was susceptible to a single nuclear bomb. The prospect of the USMC and Army combining remained unabated, much like President Truman's suggestion after World War II. The Navy Administration and Office of the Secretary of Defense opposed the tilt-rotor project, but legislative pressure prevailed. In 1983, the Navy and USMC received the initiative. The USMC, USAF, Army, and Navy requirements were unified by the JVX. For initial design work, a call for bids was published in December of 1982. In May 1988, the first V-22 was made available to the public. The U.S. Army exited the program in that year, claiming the necessity to concentrate its funding on other urgent aircraft initiatives. Number 4. A design summary. The Osprey, which has one 3-bladed prop rotor, a turboprop engine, and a transmission nacelle positioned on each wingtip, is the first production tilt-rotor aircraft in the world. The Federal Aviation Administration has given it a powered lift aircraft designation. It normally functions as a helicopter during takeoff and landing, with the rotors horizontal and the nacelles vertical. Once airborne, the nacelles swivel forward 90 degrees for horizontal flight in as little as 12 seconds, transforming the V-22 into a faster, more fuel-efficient turboprop. The nacelles may be slanted forward by up to 45 degrees to enable STOL rolling takeoff and landing. There may be other orientations. When in aircraft mode, pilots compare the V-22's feel and speed to that of the C-130. Its ferry range is more than 2100 nmi. 1100 nmi is its operating range. The V-22's exhaust heat has the potential to harm ships' flight decks and coatings. Portable heat shields installed beneath the engines were NAVAIR's interim remedy. Operational adjustments similar to these are needed for the F-35B. DARPA asked for suggestions in 2009 for installing reliable flight deck cooling. The USS Wasp has been used for testing Thermion, a heat-resistant anti-skid metal spray. Number 3. Propulsion. Drive shafts link the two Rolls-Royce AE 1107C engines of the V-22 to a single central gearbox, allowing one engine to power both propellers in the event of an engine failure. Both propellers may be driven by either engine via the wing drive shaft. The V-22, however, is often unable to hover with only one engine. When a prop rotor gearbox malfunctions, it cannot be feathered, and before an emergency landing, both engines must be shut down. The low inertia of the rotors contributes to the poor auto-rotation properties. Number 2. Flight testings. On 19th of March 1989 in helicopter mode, and on 14th September 1989 in fixed-wing configuration, the first of 6 prototypes made its maiden flight. In December of 1990, the third and fourth prototypes successfully completed the first sea testing aboard the USS Wasp. In 1991 to 1992, the fourth and fifth prototypes collided. The V-22, now known as the V-22B, underwent a redesign from October of 1992 to April of 1993 with the goals of lowering empty weight, streamlining production, and lowering construction costs. After the prototypes underwent safety revisions, flights were resumed in June of 1993. In June 1994, Bell Boeing was awarded a contract for the Engineering Manufacturing Development or EMD stage. Additionally, the prototypes were changed to look like the V-22B standard. Testing at this point concentrated on extending the flying envelope, determining the flight loads, and assisting with the development of the EMD. Up until 1997, early V-22s were still being used for flight tests. Up until 1997, early V-22s were still being used for flight tests. At the Naval Air Warfare Test Center at Naval Air Station Patuxent River in Maryland, flight testing of 4 full-scale development V-22s got underway. The first EMD flight occurred on February 5, 1997. Number 1. Controversies with V-22. Due in part to significant cost increases, some of which were brought on by the need to fold wings and rotors to fit onboard ships, development took a long time and generated controversy. The budget for development was initially established at $2.5 billion in 1986, and it was expected to reach $30 billion in 1988. $27 billion had already been invested by 2007, and an additional $27.2 billion was needed to meet targeted output levels. The expected lifetime cost of the V-22 increased by 61% between 2008 and 2011, mostly due to maintenance and support. Although theoretically capable of auto-rotation and helicopter mode if both engines die, a safe landing is tough. Well guys, let us know your thoughts in the comments down below. If you enjoyed the video, let us know by smashing that like button, and if you haven't done so already, then don't forget to subscribe to our channel and hit that bell so you don't miss out on future videos going forward. So until next time guys, take care and adios.